Hi, welcome back to Perceive 2021. I'm really excited about our next guest. He's been in the natural language processing arena for many years. Please give a warm welcome to David Taubenheim. He's a senior data scientist at NVIDIA, and he's here to talk to us about how to uplevel natural language processing into conversational AI. David?
Thank you for that introduction, and I'm very glad to be here at Perceive. Today, I'm going to talk to you about leveling up your natural language processing into conversational AI. There's a distinction between the two things. I'll explain what that is and tell you a little bit more about it. I'll give you some examples. And I'll tell you about some of the challenges to create a performant natural language processing system and how you can accelerate the NLP stack using NVIDIA GPUs and software development kits. I'll show you a list of pre-training AI models that are for your use, that you can use and use and fine-tune toward your own purposes. And then I'll give you a little tour of our Riva software development kit for conversational AI. Many of you probably do know who NVIDIA is already, so I don't want to spend a whole lot of time on an introduction, but I do want to at least expose you to some of the other things you might not be aware of that NVIDIA is working on in the artificial intelligence arena. Of course, we have natural language processing, which is the subject of this talk, but AI really does permeate a lot of other fields, including gaming, of course. That's in NVIDIA's business for many years now with deep learning super sampling to create high res from low res video, face video to video, where we can use a video of your face to control an avatar or another person's face. And we're actually going to talk about that a little bit. And then other things too in the sciences, such as Biomegatron, which is a medical language model, or even into modeling quantum chemistry. But to the subject at hand, let's talk about natural language processing. What is it? So we start off by thinking about the very basics, automatic speech recognition. This is when speech is transcribed into text by a computer. Sometimes this is called speech to text, and we don't need to worry about the differences, which are very subtle, between STT and ASR. But really the meat of where things become interesting is with natural language processing and natural language understanding. This is a field that is burgeoning now, and to do it right takes a lot of AI training of deep learning models. Things like named entity recognition are very popular. This allows you to have a text that is then analyzed by the deep learning model into natural entities. They can be of your definition, but think about this as terminology or who, what, where, why types of answers to questions. Some people refer this as slot filling. We can also do question answering, where we query a piece of text with a natural language question and the response comes back in natural language as well. To machine translation, it turns out that many AI machine translation systems are now besting human translators at accuracy and definitely at speed. And there are other tasks here too, so many that we just don't have time to go through: summarization and paraphrasing, punctuation restoral, and text generation and completion. Once you've understood the text that you want to process and act upon, it's also possible to speak back with a computer-generated voice that is very natural. And I'll have examples of that for you too. This is called text-to-speech. And we've taken this a step further by introducing emotive speech synthesis and voice cloning into the mix to make these conversational AIs more and more realistic and more human-like. Now that we know what natural language processing is, let's compare it and contrast it to conversational AI. So transactional is one way to think of natural language processing, but conversational is where you can engage in a dialogue where the natural language understanding, NLU, system is capturing context and providing intelligent responses. But the responses need to be really fast, like ideally 300 milliseconds or less in order to have a conversation. You can imagine how unsettling it is when you've experienced that delay during a call on a video conferencing call on Zoom or WebEx or whatever. If the delay gets up to about a half a second, people start to talk over each other, and It's unpleasant, unsettling, and it's actually really hard to communicate, even for that kind of delay. So we need to be able to get this delay down short. We also need to be able to use context and nuance. So previous interactions with a conversational AI system need to be remembered in the current interaction. If you have a case where a shopper is asking about an item, if you knew the previous queries, that might impact how you answer the question about the current query by the shopper. And then finally, these deep learning models are getting really large, and they still need to be real time despite being very large. I have an example of some of the sizes of these kinds of models that I'm talking about right now. I'm coming up here soon. So you recall that the real-time applications like conversational AI need to have these latencies of a third of a second or less. And let's actually walk through what's happening in that 1/3 of a second. Let's say we have a system that needs to take a question in one language and then answer it in another language. So first we have the question in Spanish, and in this case, we're asking what day it is. That comes in as audio. An automated speech recognition system will extract features, apply an acoustic model, a language model, and then using a deep learning decoder, go ahead and produce text that is then passed into what we call downstream tasks for natural language understanding. These are things like searching based on a query, auto-correcting. So if there's a mistake that's damaging the query, we can apply a language model and fix up the request in case ASR had an error. Or if somebody typed a question, we could fix that as well. Machine translation, we can take the response that we get back from our query system in our search ranking and then cast it into another language and then speak that language back using a text-to-speech system comprised of a speech synthesizer and a vocoder. And then the answer comes out as audio. In this case, today is the 13th of October. So thinking through everything that has to happen here, there's a lot to appreciate about what needs to go into some of the systems, the conversational AI systems that we're familiar with right now as intelligent agents. A lot of these digital assistants by vendors like Amazon, Google, Apple, Baidu, and so many others are relying on acceleration to get this job done fast so users have a good experience. But it gets even more challenging as time goes on. And the reason is that the queries are getting more complex too. It's less about simple questions about what date it is, and more like, what are some different types of lighting for a living room? So in this case, we have to do not only an audio search, we have to do a bit of a visual search rather as well. So we would take that audio in, process it like you see on the right, through many of the same processing stages of ASR, the natural language processing and understanding. Then we also have to do object detection and decoding of imagery in order to recognize objects that might be in a video frame that's presented to us. Then we rely on even scraping the web for answers or news or social media, then coming back with a text-to-speech answer along with a visual representation of the answer. In this case, the answer is ambient, task, and accent lighting. Still, all of this has to happen in a third of a second and preferably less. Certainly possible using today's technology and using kits from NVIDIA and some of our partners as well. I will also add that to do this could take 20 or 30 containers, if you're familiar with containers, to do. A lot of times these containers are containing different features that pertain to natural language processing, maybe a different processing stage, or maybe some kind of other web querying system, say like a deep learning recommendation system that would come back with an answer for you. Well, how does this work? And what if you had to make your own deep learning model to take care of one aspect of this conversational AI system? The good news is that as complex as this is, NVIDIA provides pre-trained free models for you for automatic speech recognition, image classification, object detection, language modeling, speech synthesis, and more. So these pre-trained models that are available on ngc.nvidia.com can be pulled down by you and your data scientists colleagues to be fine-tuned toward a particular domain. We refer to this as domain adaptation. So you would prepare your data, train it at scale using PyTorch, TensorFlow, MXNet, or another framework that you're familiar with. You can then optimize that model for inference using TensorRT. It's going to look for opportunities to prune, to combine layers, and to generally increase the inference speed of your model. Remember, we have to get everything down to under 1/3 of a second, and then deploy at scale. I'll have a tip for you about how to deploy at scale coming up here very soon. We know already that there's an explosion of deep learning models, and certainly you appreciate that the complexity is increasing. On the left, just a smattering of some of the kinds of deep learning networks that you'd expect to encounter, not only for natural language processing, but for image processing, computer vision, intelligent video analytics, text analytics, and so much more. But I'd like to draw your attention to the right. Just in the last few days, in collaboration with Microsoft, NVIDIA announced the Megatron Turing natural language generation model. And what's particularly noteworthy about this is that it's over 500 billion parameters. And so if you look back in time at the graph on the right, you'll see it was just last year that a large language model for generating language was 17 billion parameters. So this accounts for quite an increase in a short amount of time. And the amount of proficiency that the language model has also increased. These language models, like this large Megatron Turing model, are able to generate language, comprehend what it's reading, answer questions, but also reason in a common sense way if you were to query it. So the state of the art is increasing, but it doesn't necessarily mean that we have the luxury of answering questions more slowly in a conversational AI system. Now let's put this together and figure out how to put the pieces in the right arrangement for our conversational AI system. The first thing we need to do is to think about the end-to-end deep learning workflow. Some of you might already be familiar with this, but I added this as a nice resource for your subsequent reference, where you can look at names of the tools that we use every day in our own flow and that a lot of our customers and partners are also using. You start with a pre-trained model, or in some cases an empty model. You train it with new data. You can optimize it using NVIDIA NEMO or transfer learning tool, or now the TAO tool, which is train, adapt, and optimize. So that can be used for domain adaptation. Then once the model is to our liking in terms of performance, we think about ways to prepare it for deployment. I mentioned one of these already, TensorRT, that's going to seek to reduce the inference time using our model. But then we have to think about inference at scale. And for this, we use the Triton inference server. It's one of our recommendations, and I'll show you a little bit how it works in a moment. But it doesn't just have to be Riva, which is our conversational AI SDK, but also video processing, say DeepStream, if you're familiar with that, can also run using the Triton inference server. And then when it comes to our infrastructure, we have to kind of blow out past just one machine. And for that, we use Kubernetes and NVIDIA's GPU operator to deploy in production. So let me give you 3 examples of Riva, the conversational AI SDK in action. One of those is an automotive virtual assistant. When the driver or the passenger looks over at the camera that Riva's monitoring, it will become activated, and we call this look to talk. It's a feature that's coming soon into Riva. Then ASR will transcribe the user's speech. A dialogue manager will keep track of each person's history and the kinds of query they're making. In this case, Shirley, the passenger, asked how the weather is, and Riva responded. The assistant will then perform the necessary search functions and any kind of necessary network outreach to the web, say Wikipedia or social media or other kinds of data sources, along with your very own internal repository of data, and then answer with natural sounding speech in a car. So to do that, Riva is going to apply pre-trained models that have been optimized using the TAL toolkit in Riva's skills, such as noisy environments, accents, jargon, scripted phone. Those are things that are difficult for ASR sometimes, and you can fine tune for your own environment or jargon. The dialogue manager is handling the exchange of information between the ASR and the natural language understanding, question answering, that is querying something like a manual or a database of natural language source material, and then contextual understanding along with sentiment. What is this person really asking? Is it in general the weather, or are they upset about something? For example, it's possible to deploy Riva with just really a line of code. I recommend you take a look at developer.nvidia.com/Riva to get instructions on how to download it and begin using it already. It's free and it's pretty easy to use. Sorry about that. So Riva has a number of pre-trained models that are part of it, but I wanted to expand the set past Riva also to show you some other models that are important for you to know about. From ASR, which we already discussed, automatic speech recognition, to natural language processing, like named entity recognition using BERT as a transformer model, to a machine translation where the models and SDK that we provide for your use for free span a number of different languages that I'll show and are quite performant, scoring competitively in global competitions, to generating MEL spectrograms for text-to-speech with Tacotron, and then a couple of different types of vocoders that have accelerated performances and high fidelity. Here's an example of translation models and their blue scores, which are used as an objective means to rate the performance. It's kind of a de facto standard in academia and the industry to rate the performance of these models. So English to German, Spanish, French, Russian, and Mandarin, and vice versa. And what I'll mention is that this news just in, the NVIDIA team scored an impressive 77 as the blue score, winning the WMT 21 competition. This is the highest score that's been seen to date in Russian to English translation. So these are both real-time and offline models that you can use, transformer-based, sequence to sequence like you'd expect, and have under 100 milliseconds of latency per second. You can use NVIDIA's NEMO tool, which I talked about before, to fine-tune some of these models. So if you had a particular domain of technology or jargon that you'd like to train a translation model toward, it's certainly possible without having to completely retrain the model from scratch, which is a lot of time and a lot of work to get right. And so these models can work with both Riva, but also your own application. Again, available for free on ngc.nvidia.com. You might remember that I talked about how to infer really fast. And to do that, we recommend the Triton Inference Server. The Triton Inference Server will take in a number of deep learning models, and they can be heterogeneous in function. So computer vision, natural language processing, text-to-speech recommendation systems, text processing, and keep those models handy in GPU memory for deployment across multiple frameworks that are being served by the inference server. So imagine this, you have many different users on a network. These can be internal users in your own firm or customers outside that are making requests for translation, for object recognition, for any of these services in Riva I just talked about. And Triton is balancing the load and serving up the models by using a configuration script that you don't even need to worry about coding in. It's possible also, and we see this especially with complex systems like, say, OCR, optical character recognition, where you have to chain together an ensemble of models. This is supported in Triton and very important in many fields. The second example, and I wanted to take a little digression from the first example to spell out how it works before coming to this second example, is when we can help you with a chatbot application. And so Riva comes with examples of not only performing transcription and named entity recognition, but you can put these into a live action. So imagine you have a call on a video conference service like Zoom, say, and it's, you'd like for the dialogue to be not only transcribed and stored, but then also processed with natural language processing for named entity recognition. So you can have things like medical terms tagged using the NER deep learning model. So just a basic application that you can take a look at as an example of Riva when you download it. The third example is neural machine translation. And you see a little clip that I included from our GTC conference from earlier this year, where our CEO Jensen was giving an example by speaking in English, and the live transcription was coming out also in Japanese. And so this is a highly performant, more than 90% accurate out of the box, available to be fine-tuned for your application. And we currently support the languages listed here. I should also mention that these are soon to become available in embedded versions so that you can use machine translation in small devices like this Jetson Xavier NX. I'll just give you a very quick vignette of a testimonial. Kensho and S&P Global were able to fine-tune the ASR model to optimize it for financial audio. So you can imagine these financial calls, they have to be accurate when you're having a shareholder call, for example. And so Kensho and S&P Global fine-tuned an ASR model for performant accuracy in the domain of finances to achieve a very good, and if memory serves, on par or superhuman ability to transcribe these tough calls. They have telephone quality, a lot of jargon, and some background noise. And so excellent application of Riva's resources.
Hello. Yes, I would like to buy some blinker fluid, please. That's right. Yes. Do you also carry brake light fluid?
So the example you heard was a pretend phone conversation, one side of the conversation anyway, as spoken by my colleague Josh, but not really. In fact, that was a voice cloning deep learning model produced by our RAD TTS, RAD text-to-speech method that is currently the subject of research at NVIDIA. But the thing is, the phrase was actually originally spoken by me. Here's me in the recording. Hello. Yes, I would like to buy some blinker fluid, please. So this new RAD TTS method is able to take one voice and use it to drive another voice and preserve the cadence and pitch changes and expression of the original voice. So let me also show you what else is possible. We can, by creating a voice model of somebody through recording their speech and then processing it, we're also able to preserve accents. So Michael, another one of my colleagues, learned English as a second language. Yet when I'm driving his voice model with my voice, an accent still comes out while still preserving my original cadence.
What do you mean you're out of blinker fluid? That's preposterous. We talked about this yesterday.
So these deep learning models representing voices, voice clone models, are able to capture accents as well. or even gender. In this case, I'll take the famous Sally voice model and then apply my voice to drive hers as well.
What do you mean you're out of blinker fluid? That's preposterous. We talked about this yesterday.
So definitely a lot of potential here to create natural sounding conversational AI systems.
What do you mean you're out of blinker?
Sorry about that. And then finally, another thing that's next is NVIDIA Maxine. We're looking to reinvent the video call. So rather than transmitting a video, maybe with a compression protocol like H.264 or others, and taking a lot of data to do so, what if we were able to track the facial landmarks around your face using your webcam, transmit those along with your audio to the other side of the conversation, then reconstruct an animation of your face that's virtually indistinguishable from the video that would have been sent, except for contain much, much less data, less than 1/10 of the original data rate. This is what Maxine strives to bring forward. But there are some other aspects of Maxine that are, I think, pretty compelling. One is face alignment. For example, right now I'm looking off to the side as I'm looking at the slide, but Maxine will be able to realign my face so that I'm looking right at the camera, apparently making eye contact, even though originally the person is looking at somewhere else on his or her screen. But once we're to that stage, it doesn't even have to be the original person's face anymore. It could be an AI avatar that's speaking on the other end. And while this is a lot of fun, it's also possible to put another person in so that another person's persona, perhaps an actor, is being spoken using a cloned voice as well. So a lot of really interesting applications, and I think some that we have to think about very carefully as well. And then finally, translation. While I showed you an example of Jensen's speech coming out in a different language and text, we're also working on a future version in which it's possible for my voice to speak another language as translated instantly by Riva SDK. So thank you very much. I hope this gave you a flavor for not only how you can build a conversational AI system, some of the considerations that you have to take into account when you do put one into place, the tools that are available for your use today, many of which are free, and then finally, what's next? So thank you very much, and I'll hand it back.
David, thanks so much for joining us on our virtual stage today. It was a pleasure to learn about the state of natural language processing and what you're doing to address the growth of conversational AI. So thank you very much. Big round of applause from our virtual audience, and we'll see you at our next session.